A very good day to you all and a warm welcome to this webinar, jointly hosted by the IFST Food Safety Group and the newly established Food Processing Group. My name is Chris Edwards. I work for Muller in the county of Shropshire, where I'm head of quality for 3 yoghurt and dessert processing plants. I am chair of the brand new IFST Food Processing Special Interest Group, and I am joined today by Deborah Smith, events lead for the group. This new group covers all areas relating to engineering, manufacturing, continuous improvement, as well as equipment. It also considers topics such as preservation, robotics and artificial intelligence, materials and hygienic design, and lastly with a heavy interest in youth and youth development in this area of interest. So without much more of ado, I would like to hand over to Andy Kerridge, who is Vice Chair of the IFST Food Safety Special Interest Group. Andy.
Thanks, Chris. The IFST Food Safety Group covers areas related to safety, including chemical, microbiological and physical contaminants, as well as allergens. It also considers topics such as analytical techniques, food safety culture and food fraud prevention, and contributes to relevant publications. It provides members interested in food safety with an opportunity to engage and share knowledge. Feel free to make comments and ask questions throughout the webinar using the Q&A function, which should be at the bottom of your screen. There will be a Q&A session after the presentation where we will respond to as many of these questions as possible, and Deborah Smith will ask the speakers your questions.
Okay, great. I now have the greatest pleasure to introduce our 2 speakers today, and they are Simon Pearson and Martin Howarth. A warm welcome. Simon as Director of the Lincoln Institute of Agri-Food Technology, where the institute itself sits within the university campus and helps develop and run cross-disciplinary research subjects on behalf of the agri-food sector, with particular focus on the use of and deployment of agri-food robotic systems. Prior to joining Lincoln, Simon was CEO of a large farming company, worked for Marks and Spencer's in a technical role and as a scientist at the University of Reading. Martin as Director of the National Centre of Excellence for Food Engineering, where Martin himself leads the Sheffield Hallam's University's Food Engineering Research Programmes. He works closely with the food and drink sector, where the centre collaborates regularly with food companies from a multitude of multinational organisations, right through to SMEs. Martin himself has a PhD in robotics and is a member of the Institution of Engineering and Technology and a chartered engineer. For more information on their biographies, please look on the IFST website. So without further ado, can I hand over to you, Simon, please?
Thank you for tuning in. My name is Simon Pearson. I'm Professor of Agri-Food Technology at the University of Lincoln. And my talk today is going to be about robotic adoption and development across the agri-food sector. And just before we start, I'm going to give you a quick overview about what we do at the University of Lincoln. We operate across 2 sites with quite a significant footprint in agri-food. I work out of Rhizome. There's a lovely picture here of the Bishop's Palace, which is our headquarters, which is sort of this very large, wonderful estate north of Lincoln, where we do more of the agri research and some of the refrigeration research. And then we've got the National Centre for Food Manufacturing, which many of you know, and that's based at Holbeach, where we have a very large training programme for apprenticeships, but also lots of research, and including we've hosted the OAL's robotic chef, a robot called April, which is shown in this slide. So we've got quite a significant footprint in agri-food at the University of Lincoln. One of the reasons is clearly there's quite a large cluster of the agri-food industry in Lincolnshire, and I'm Director of the Lincoln Institute of Agri-Food Technology, and we've got quite a large focus on robotics. I suppose that's what we're known for, and a number of key projects ongoing. First one is a Research England grant called Lincoln Agri Robotics. That's 30 members of staff, professors, engineers, postdocs, lecturers, PhD students. So 30 of them all working in agri-robotics, and some quite large capital facilities associated with that, including UK's first 5G private testbed for the agri-food industry. That's at Rhizome. We've got Agri-Forwards, which is 50 PhDs joint with Cambridge and UEA in agri-food. So that goes from agri all the way to food manufacturing, and they're recruiting now. I think with those 50 and other PhDs, we've now got a pipeline of 65 PhD projects which are going to be ongoing from now for the next 8 years. So a fantastic pipeline of talent hopefully coming through to the industry. I'm PI of the Internet of Food Things Network for the IFST. That's looking at digital technologies in the food chain. That spun out of the Made Smarter initiative. But digitisation across the whole food chain, from farm to factory to consumer to fork. That's the Internet of Food Things. We've led large research initiatives with the Food Standards Agency on data trust, data sharing in the food industry, use of blockchain technologies, distributed ledger technologies, all sorts of things which are driving the future of food around digitisation. Then I work with a grant called Ceres, which is with Cambridge, and that's a spin-out grant for university research. I think we've got six of our projects which are now in the Ceres phase, and hopefully those projects will be coming to market within the next year to 2 years. So quite a lot of very applied, very industrial research going on. We get funding from 6 of the main UKRI research councils, which are on the left, and we've got funding from 4 of the Industrial Strategy Challenge funds, so Transforming Food Production, Robotics for Save the World, Made Smarter, and Driving the Electric Revolution. So we're a very interdisciplinary institute. We have quite a large reach across the whole of agri-food, all the way from farm through to the consumer. So I'm going to talk about why robotics and why not robotics. And I've only got 15 minutes, so it's quite a short talk. But first of all, why robotics? Well, it's all about productivity. I've worked in the food industry for many years before becoming a lecturer. I understand the pressures under the sector, and it's extremely competitive, very, very fast moving, and lots of uncertainty. Huge pressure on labour, so resource efficiency, and also non-labour productivity. So trying to reduce waste and trying to squeeze as much value out of every ingredient that's coming into the food sector. And then it's an industry that's facing unprecedented risk, and it's Brexit. Now I think sort of 50 odd days away. It's not that far away. Still uncertainty what the environment's going to be, the trading environment's going to be. That's complex, but access to labour is a known issue post Brexit, with the cut down on seasonal migrant workers coming into the industry. Several tens of thousands working in food manufacturing across the UK, and some uncertainty about that going forward. And then COVID obviously has had dramatic impact not only on labour availability, but coding, seeding in food factories and all those sorts of things, which are very widely reported. So why robotics? Well, it's driving productivity for the sector and helping de-risk the sector from some of those issues. Why not robotics? Or why aren't we seeing robotics going at the same rate they've gone into the automotive industry and aerospace? Well, flexibility, particularly on chilled foods and those sorts of goods where you've got very large numbers of lines, rapid changeovers, uncertainty of orders. So flexibility has been an issue, but also risk. So they are extremely large and significant capex costs. Lack of certainty that you're going to get an ROI over the period of a supermarket contract. So that's been one of those things that's always been an elephant in the room. And complexity, it changes the basis of skills within the factory, and not all, many they are seen to be very, very complex pieces of equipment. Not necessarily so, but that's one of the things why people have not gone for robotics. So lots of need for robotics and lots of things we need to do to get robotics in. What are the key robotic research challenges which the industry needs to consider? And I'm really trying to put this now in the perspective of a roboticist. And on this slide, I just want to refer to a white paper that we did, which is called Agriculture Robotics, but it's very much the same for agri-food robotics, which we did for the EPSRC 2 years ago, which is a precursor for the CDT Agri-Forwards that we've won with Cambridge and UEA. And what we tried to do was really look at it not necessarily from the agri-food producer's perspective, but from the roboticist perspective. And why would roboticists want to get involved in our industry? And we think the reason is there's lots of very significant challenges. It's a very exciting space for research. And those research questions range from mobile autonomy. So there's a need for AGVs or autonomous guided vehicles going through food factories or through fields. That requires very advanced algorithms on autonomy. So the robots need to navigate around factories in a safe manner and not run people over, get from place to A to B, and it all needs to happen seamlessly and autonomously. And we're seeing this in Amazon warehouses and Ocado warehouses. Those are all great examples of autonomy, but it's a very active research area, and there's lots of challenges still remain in that field. Agri-food's fantastic next challenge, which is manipulation and soft robotics. So you're dealing with biologically soft tissues, biologically variable tissues. You've got to have machine vision, which understands those tissues. You've got to be able to image them. You've got to actually sense them and perceive them, but then you've got to then move robotic actuators to manipulate them and grasp those tissues. So lots of interest in manipulation and soft robotics because it's biologically very diverse, so complex for robotics. And then you've got to then have the sensing and perception, which then matches that can actually detect, predict, and understand what those objects look like and how to move to them and interact with them. So sense and perception, very big. Then fleet management. You're dealing with tens of thousands of people, very big mega industry. One robot is never going to do it. So you need N number of robots. So really a large fleet of robots. How do you then orchestrate them? How do you manage them? How do you control them? How do they know which job to do? It's very, very complex. So there's a very big piece of sort of fleet management. And then above all, in factories, it's about a human-robot collaboration. So how do you get those robots to interact safely with people so they don't harm people, run them over, hurt them in any way? And that's around collaboration. So collaborative robotics is very, very important, particularly in food factories where you've got people already in those factories. Then you bring it all together around systems integration. So you've then there's lots of challenges in how you actually integrate all these technologies together. Very, very challenging indeed. And then you then apply those crafts in the domain. So in terms of crop management, food manufacturing, fisheries, plant sciences, logistics. So lots of domains to use all those robotic technologies. So it's a really hot and interesting area for roboticists to work in. But those are actually all of the problems that you've got in the food industry in terms of applying them. So you need people who can solve the autonomy issues, the manipulation issues, the fleet management, the robot issues. So how do we go about it? So I just want to show a couple of videos now of what we're doing at Lincoln. The first one's on NCFM, which is a robot called April, and I thank OAL, Olympus Automation, for this video. And they have a robot, which is a very large KUKA robot called April, which is a great example of an industrial robot manufacturing food. And this system's now being marketed worldwide. It was demonstrated as for the Made Smarter review in 2017 to Sir Mark Walpole and Jürgen Meyer as one of the leading examples of robotics in the food industry. And so, what is that robot doing? It's automating a standard manufacturing operation, a cooking operation in the food industry. The robot takes payload of I think 900 kilos, so very, very significant weight, and that moves that cooking cell around the factory in a circular manner. So it's automating a very standard factory process. So that's April, that's at NCFM. And then what do we do at Rhizome? So we have a large number of robots which are operating. This is just one in a fruit farm. It's a robot called Thorvald, which is it's basically AGV. It's a very complex navigation stack, which is wandering up and down these fruit. And this one's counting fruit numbers for fruit forecasting. And that's the robot again in our fruit farm. And this just shows a good example of AGVs. So that what we're trying to do here is pick fruit. You see the pickers in the top of this video. They're picking fruit on a normal trolley, and they're going to call a robot autonomously with a mobile phone. The robot is called. The robot has to find those pickers. So there it goes. There's one. Take the fruit and then it whizzes it back to a pack house. So fully autonomous operation. And then machine vision, which you'll see in food factories on any line, some very complex challenges with occluded fruit. This just shows some of the machine vision work that we've done on strawberries. And before you pick a fruit, you've got to be able to recognise it, size it, determine whether it's ripe, and then determine which ones you're going to pick. And this is the machine vision pipeline that's underpinning lots of our robotics research on fruit picking, but it's exactly the same as in food factories. And how does we do that work now? It's all with digital twins, and this just shows some of the digital twin work in robotics. And in COVID, we couldn't go out and do research, so we worked in as a digital twin. And this is a gazebo model of a fruit picking robot, which was got a full CAD package, operational CAD package, physics of the robot, but also inside that robot you've got the control system, the coding, the details of how it perceives the fruit, and a full simulation of how it picks fruit. So this is what we were doing in the spring during COVID, so working very actively on digital twins. And then post-COVID, we then went out, not post-COVID, we're in the middle of COVID now, but when the fruit were ready, we went out, tested that robot, and I can tell you it worked pretty much first time. And here it is. That's how you've seen the digital twin. This is the robot in the real world, and it's found a fruit. It's going to move up to that fruit, and here we go. It's opening up. Here's a picking cup, and it's going to pick that fruit. And all of that work was done in a digital twin environment in the spring before any fruit existed on the bush, and because of COVID, people couldn't work together. So it's been a brilliant way to accelerate robotics. And that system's now been further developed. It's been speeded up, and here we go, and it's picking some fruit. So it's going to pick the next one. And this just shows the robot now working at a more effective speed. So we really are making very significant progress on a number of these challenges, and we think certainly on strawberries, if you can pick a strawberry, that's one of the most challenging robotic challenges, because you've got to identify that fruit, you've got to pick it, you've got to do it without bruising it, and you've got to do it at very high speed. And if you can do that, I think many robotic challenges are solvable. So that's video. I'm going to go on to the final slide now. So and what are criticalities? What's the big barriers? And we're finding the big things which the industry are telling us. It's access to trained people. So as we undergo this transformation towards robotics, we need more and more people who understand about robots, not necessarily roboticists, but people who understand about the application of robotics in their factories or in their businesses. That is an issue, and we're trying to help with that training. What we find, it's all about interdisciplinarity and networking. Roboticists are great. They love working in agri-food. Agri-food industry people like talking to roboticists, but it's just very important that we keep that interdisciplinarity together, that we keep that community vibrant, interacting all the time, because some of these skills are actually quite unique, quite niche, and it's that ability to network. It's been very important to actually create effective solutions for business. Then it's about scalability. It's very expensive dealing with robots, and clearly the solutions which are going to be advanced at the fastest rate are those which are scalable. So I think all the industry is looking for those opportunities, and that's beyond pallet stacking. And then you've got the other complexity of data handling, that you can't deny that the data required for a robot, it's absolutely enormous, and we are stepping up the data scale. So we need to think about not just the data, but the infrastructure around robotics and all those other things. So as we evolve, robotics are going to be coming through to the fore. We're going to see, I think, a very rapid rate of development of these technologies, certainly breathtaking, I think, in some sectors, and we think they will transform food manufacturing, are transforming food manufacturing. That transformation is going to go on at pace. So thank you very much for listening to me.
Thank you very much, Simon. We will now move to Martin's presentation. Over to you, Martin.
Good morning. I'm Martin Howarth, Professor of Food Engineering at the National Centre of Excellence for Food Engineering at Sheffield Hallam University. It's a pleasure to present this short talk about robotics in the food sector, beyond palletisation, or as I've called it, cupcakes to AI in 5 easy steps. I will provide a short introduction to food engineering at Sheffield Hallam University, and then a few insights and my perspectives of the current and developing technology which is bringing robotics to the food sector. I have some industrial examples of some which are starting to emerge from university laboratories. The National Centre of Excellence for Food Engineering only opened its doors in 2019 after an £11 million investment from HEFCE and ERDF. It contains food-grade processing spaces which replicate best-in-class food manufacturing infrastructure. We bring together the best of food science, engineering and computer science at Sheffield Hallam to tackle food processing challenges. We collaborate with industry to find new, effective solutions to industry challenges, working directly with industry or with funding from government and research councils. We've worked with Nestlé to increase KitKat wafer baking efficiency. We've developed novel low-fat and low-salt cheese for Greencore and Arla, and are developing industry-leading autonomous rice milling capability in collaboration with UK SMEs and international partners in India and China. So, cupcakes to AI in 5 easy steps. What are the challenges to robotics in the food sector beyond palletisation? Here are a few of the key issues that I think are most important, in some cases challenging, but in all where there are solutions. First of all, hygienic and cleanable equipment, not originally on a robot machine designer's specification list. Secondly, handling soft and fragile material. How can soft touch and dexterity be embedded in robot systems? The next one is further challenges are poorly defined location. Does the robot know where the object actually is? Then there's high variety, often short batch runs with frequent product changeover. And also fast throughput, an area that a robot or automation should be good at, but can it cope with the other challenges? The next few slides will review some of the technology which is contributing to the easier adoption of robot technology. First on my list is hygienic design. Clearly an absolute imperative for delivery of safe food for consumption. Much work has been done over recent years to generate and to define good design techniques to support equipment being used in the food sector. EHEDGE, the European Hygienic Equipment Design Group, has established a wide range of principles and good practice for engineering equipment design, and now included in this is robot design principles. The key principles are listed here on the slide. Firstly, the correct selection of materials used for both the mechanical performance but also for cleanability and to withstand the long-term use within a wet cleaning environment. The geometry used, how does this impact on the ability to be able to keep the product clean? The joints and joining techniques, are they crevices which will harbour bacteria even after you consider it to be cleaned? The construction or fabrication details. This includes the joint and jointing techniques, but also includes the way in which material can be utilised to eliminate certain key joints and junctions within the product design. Components and their installation. How are they protected from the wet and damp environment and the aggressive cleaning materials? What manufacturing techniques for each component are used? How do these contribute to the ability to be able to keep the product clean? And lastly, and possibly most importantly, what are the surfaces that are in contact with the food products, and are the surface coatings being used contributing to reduction in cleaning times? At Sheffield Hallam, we've built up considerable expertise in effective coatings to deliver very durable but also cleanable surfaces which can be built into food equipment to reduce cleaning cycles. And by applying EH principles to robot design, robots are now being built which are both fully wash downable and have the capability to work in wet environments. One of the manufacturers who have led the production of hygienically designed and EH approved robots is Staubli. Other robots are available. A number of other robot providers are now also providing food grade machines. For example, Omron have a range of food safe robots. The food grade Staubli machines are both hygienically designed and are fully wash downable. And from an engineering perspective, the details from the surface finish to the joint and seal design, positive air pressure inside the arm, and the minimum of external connections is very good. If nothing else, it's a great case study for engineering students who want to understand how to apply their knowledge to food systems. The next issue on my list is the challenge of product manipulation or grasping. I found that the work of the Festo bionic system developments both fascinating and inspiring. The image at the top right shows one of their ideas inspired by animal behaviour, which shows a technique to grip unusual shapes and products which vary between individual items without additional programming and without damaging the product. These design principles are the ones that we need to adopt and build into products that are used within the food sector. The food sector is, of course, full of challenging materials which exhibit these challenges. But through investigations at universities and by engineers like those at Festo, commercial solutions are now available. And here, shown at the bottom right, is the solution to my problem: how to manipulate cupcakes without damaging them. The solution is by Soft Robotics, and this flexible gripper is available commercially. It is both hygienic, both in terms of the materials used and the ability to clean the complete mechanism. It's very soft, doesn't crush the cupcake, and is very effective at moving it at rates far superior to manual manipulation. The next key issue I have on my list is that of sensing. As food scientists, we want to ensure that products that we produce are both ready for consumption, don't contain any foreign bodies, and are safe to consume. Thankfully, sensing techniques are also at a late stage of maturity, providing a wealth of information to assist in the automation process and to check whether there are any damage or any material contaminants within the product. So whether we want to know where the product is, or to check if there are any contaminants in the product, or to confirm that the product is packaged correctly, there are now sensing systems to help. The top right image shows the use of terahertz imaging to show the presence of foreign bodies in the product. It's actually an illustration of crickets embedded in flour and is based on some work by colleagues at Sheffield Hallam. The middle image shows the use of hyperspectral imaging, which is particularly in the near-infrared spectrum, and identifies peanut contamination in flour. So the further you go to the right, the higher proportion of peanut contamination. And so you can see that it's relatively straightforward to identify from a low level and increasing levels of peanuts contamination within the flour. And the bottom image is also of hyperspectral imaging, showing a seal in a pack which is poorly formed and contains a piece of stray material which is preventing the seal from closing correctly. This is a commercial image illustrating that this technique is now ready and available for applications within food application and food manufacturing. My penultimate topic is that of collaborative robots. Robots which are safe to interact with. This is a topic which has gained a lot of interest over the last 2 or 3 years, and is seen as an ideal opportunity to actually provide the best ways of working to actually get the best out of a mechanical device, but while still getting the intelligence and the dexterity from manual operators. The idea is that the manual operator is able to work in close proximity with and can assist with or be assisted with tasks with the aid of some relatively sophisticated automation devices. However, the example shown here is a machine which is collaborative, but it's slow, has relatively low power, and I don't think these are the solutions for the food sector. The photograph shown in the bottom right is of a commercial device, but I don't think it's been hygienically designed, and it would not appreciate being washed down. Developments over recent years have produced systems which enable the principles of safe zones to be implemented, and enabling systems to be designed without physical guarding. Using lasers, cameras or radar, often in combination to minimize blind spots, and linked with the robot controller to slow or stop the robot if the operator moves into a specified zone nearer to the robot. Safe zones can be defined which allow operators to work within the workspace of the robot to produce robot systems which combine speed, dexterity and power, i.e. to provide effective collaboration to get the best from both the robots and staff in a safe environment. In other words, to utilize the capability, the intelligence, the challenge solving capability of the operator with the ability of the robot to actually take away the hard work and to be able to move things at high speed. The last item on my list is AI. In other words, how can automated systems improve their capability and to make decisions which are challenging to program conventionally? My PhD many years ago utilized artificial neural networks to embed autonomous behavior into robots. In actual fact, I was embedding the capability to learn dexterity for a robot to enable mechanical assembly to take place. These techniques have been developed over recent years and are now real, available and applicable. Building them into the suite of robot systems is providing new capability for robots in the food sector, enabling robots to be applied to more challenging and complex tasks. Researchers at universities continue to work on these challenges, but applications are now ready for adoption by industry. The images shown here are examples from Sheffield Hallam, where computer scientists are applying AI techniques to manipulate food products in a range of structured and unstructured food environments. The work has developed new learning capability demonstrated with these systems, and illustrating how data is handled and exchanged in a flexible way, and providing learning capability leading to autonomous behavior. This is my last slide. So in summary, I hope I've given you some new insights into robotics for the food sector and my 5 easy steps from cupcakes to AI. In summary, hygienic design is key. Manipulation of the wide and variable materials and products is challenging, but there are solutions. Advanced and effective sensing techniques are available and enabling robotics to be applied to more challenging food applications. Working with robots has previously been for the programmer only, but new monitoring or sensing techniques are enabling operators to work alongside robots to get the best from operators and the automated equipment. And AI is enabling even more challenging applications to be solved for the benefits of food manufacturing. Thanks for listening.
Thank you, Martin and Simon, for some incredibly interesting presentations. I don't think I'm the only one to think that, judging by the comments that I've seen coming up on the Q&A. So we're now moving into the Q&A session for today. And just a reminder for you that you can submit questions using the Q&A function. So moving to our first question, Simon, I think you've posed many interesting points about robotics and the skills of the roboticist, but how do you see the robotics affecting the skill set required by the food industry?
Yeah, it's a really interesting question. And it cuts at many levels. I think there's several things that we've got to think about as these advanced technologies come in. We've really got to think about retaining and upskilling the existing workforce. That's the crucial thing. I think one of the barriers is this perceived complexity of robotic systems. And as I said in the thing, I don't think it's necessarily the case, but it does need a lot of training. And we really need to think about how we train existing food engineers, particularly to upskill around robotics. And there's some terrific courses. I mean, most of the big robot companies do offer training courses, but there's a skills gap. And I think the successful companies going forward in terms of adoption are going to be those ones that really think about that skills gap. I mean, we can't be dependent on going out on third-party companies bringing in skills all the time. We've got to be developing those skills internally. The other thing we've got to think about is that pipeline of people coming into the industry. How do we start that pipeline? And one of the things that we're really trying to work hard on, certainly with the CDT, is to use the kind of high-tech image of robotics, and it's got a terrific image with young people who are thinking about careers. I mean, I look at my own kids, got a TV in the background. It's not really a TV, it's a games machine, and they're very inspired. And these things are very, they're very engaging. And what we're trying to do is really try and create that engagement to get people into the food industry. Because I think if we can get people into the food industry, they'll stay because it's a brilliant place to work. But if we can use some of these high-tech things to breach that barrier, terrific. And that's one of the things that we're trying to do. And we can all do and all get involved in. I think we've got a responsibility to bring as many people in as we can, because it's a great place to be.
Yeah, absolutely. I think that those of us that have worked in the food industry appreciate that, but sometimes it doesn't seem quite so sexy to somebody at college or university. So maybe robotics will be the hook that they need to get them involved. Martin, one for you. So obviously there's the whole thing with new skills with people, but what additional requirements of equipment coming into the food industry do you envisage?
I think the biggest thing that people wanting to contribute to support the food industry, whether that's for financial benefit of the company, is centered around knowledge of hygiene and how that's actually managed within the equipment design and within the process design. In most other industries don't need to worry about it anywhere near the same extent as clearly food does. So there's a big learning curve for that. And that's why I highlighted hygiene and E-Hedge's work to actually design and define parameters which are relevant and critical, really, not just relevant, but critical to equipment design. So in terms of broader understanding, there's an education piece there to actually support robot system integrators from other sectors to add on the additional elements that are necessary to actually include their existing knowledge in robotic applications, but within the food sector, and that's around the hygiene issues, which are absolutely critical.
Yeah, absolutely. Again, I think there's a great opportunity here that, as this is an emerging technology for the food industry, if we can work closely with the manufacturers of the robotic equipment to incorporate hygienic design at the fundamental level, then it's going to save a lot of problems going forward.
Yeah, just to add to that, there are traditional techniques for keeping things clean, which work, but are there newer developing opportunities where cleaning processes are different, equally effective, but possibly slightly different to what is currently utilized? And that's what I was trying to allude to in terms of material selection, appropriate coatings which prevents the buildup of contaminants for very much longer. And so there's quite a lot of science which is available now, which actually can add to existing techniques.
Absolutely. One for you, Simon. So many people were very impressed with your videos, your presentations there, which was great. And one question that's come through is, with the strawberry picking example, if the robots visually scan the strawberries when they move past the plants, what happens if there's a strawberry that's covered by a leaf or is in the center of the plant? Do you see plant breeders moving to breed plants that are more suitable to pick using robotics?
Yeah, it's the biggest problem in robotic harvesting is the vision system to detect occluded fruit. So we are looking at all sorts of ways of dealing with that, including active manipulation, so where you've got probes that can go in and look, but also active vision, where you might move the camera around the scene and then you create a 3D reconstruction of the scene. So it's a real hot end of robotics research. One of the reasons we do a lot on strawberries is because it's just such a great exemplar. And if you can solve robot strawberry picking, you can solve many, many problems in robotics across the agri-food industry, because it's incredibly soft. It's really hard to find. The vision is difficult. You've got to have a robot which can reach out, pick that thing. You've got to then put that fruit onto a robot, which is an AGV. It's then got to take that back to a pack house or a cold store, and you've got to have hundreds of them. So if you can advance the state of the art in that domain, we then see lots of opportunities to spin that out across the whole of the agri-food sector, AGVs, control, vision, the whole thing. So it's a lovely research area to get that scalability. And yeah, and everyone's got a role. Biologists, in terms of plant breeding, got a role. The way that we process food to make it more uniform have got a role. So it's not one individual or one group's challenge. It's a massive interdisciplinary challenge, and that's how we're going to break down some of these very significant problems. It's getting everybody on it from all perspectives.
Deb, if I can just add a little bit to that, Simon's absolutely right. The interesting challenge of computer science applications for those challenges have actually been used in other locations. I'm in Sheffield. There's actually quite a big computer gaming industry based in Sheffield. They're always looking at the ways in which, from the other perspective, of how you can create three-dimensional images of things which are realistic. Grabbing those skills and knowledge and applying it to the food sector will provide solutions for us as a sector. So the opportunities are there, I think, to take things forward.
Yeah, and in fact, a few of the comments that have been coming through have been along those lines. So importing some of the experience and skills from other industries to blend with the existing and new technologies that we're trying to take on board. So you're dipping into those areas where this technology is already used, but for a completely different reason, might be a useful way of getting some of that information into the food industry. One that's come through probably for both of you is, how advanced is the area of robotics in the UK compared with other countries?
Yeah, I don't think it would be appropriate to say we're leading, but if I look around the world, I can't say I know of anybody who is leading. What I do think is that we're internationally competitive, and we're really delighted. Certainly at Lincoln, Cambridge UEA, that we're now UKRI, EPSRC is now getting heavily involved and starting to fund lots of these PhDs, and certainly the Agri-Forward CDT. That's a very significant cluster of PhDs, which is internationally competitive. But no, it's such a fast-moving space that nobody's leading. And there's progress going all over the place. I think what I've learned is the cruciality of this. It's about the ability to collaborate and not necessarily lead. I think the key skill is to collaborate. Is to find partners, work with partners at pace, and solve problems and keep moving. So it's less about leading, more about the ability to collaborate in this space, because it's just so quick.
Yeah, Martin, have you got anything to add?
I think Simon's absolutely right. But from a practical perspective, in terms of expertise on the ground who are ready and available to actually work with the food sector directly, there are excellent systems integrators with the knowledge to work in the food sector. The problem is there aren't enough of them, and those that there are generally pretty busy. So that one illustrates their expertise. Secondly, it's also demonstrating that there's a gap and therefore opportunities. So anything that people like ourselves and Simon can do to support other systems integrators to gain that extra part of the challenge, to enable them to bring their robotics expertise to the food sector, then we are very happy to collaborate exactly as in the way Simon has talked about.
Great, yeah, thank you. So looking at it from the other side, we've had one question that says, how long do you think it will be until robotics are more widespread in the food industry? Some of the barriers mentioned at the start, including ROI based on retailer timescales and product life cycles, sound like significant barriers currently.
But on the other hand, Simon mentioned at the beginning of his talk about some of the other challenges, Brexit and staff, current staff availability. Are there enough staff to actually do the various jobs, whether it's inside in food manufacturing or outside in an agri-food setting? The UK government tried to get our own population to contribute, and that wasn't entirely successful. So there's a labour shortage looming, if not already there. It's not going to get any better. So a longer term view has got to be taken in terms of the financial justification. So looking at 12, 15 months justifications is challenging anyway, and is probably too short. And what we need to do as engineers supporting robotics in the food sector is to demonstrate the flexibility of the equipment. In other words, it's relatively straightforward to reassign it to another task later on, and therefore to reuse it and reuse the investment by reprogramming, repositioning the system.
Yeah, I think the cruciality of it all comes back to productivity and how productivity underpins business sustainability, economic sustainability, having been on the other side of the fence running one of these operations, it's so competitive and so fast moving, this business. It's unlike any other I can think of in terms of speed, complexity, pressure on margins, competition, movement of contracts, all those sorts of things. Competition from overseas, it's truly global. I think the one thing that guarantees sustainability, which everybody wants, and security, it's productivity. And it's making sure that you are the best manufacturer, whatever you do, anywhere in the world, not just in the UK. That's what guarantees sustainability. So every edge that you can take, you need to take it. And the food industries are brilliant at doing that. It's brilliantly. I've got a fantastic track record of innovation and adoption, and it's got to go. You've got to keep going. And I think what robotics does, it just step changes again. It's just another significant ramp up that scale. And if we're not doing it at home, unfortunately, someone else somewhere in the rest of the world will be. And no matter what happens with Brexit, COVID, trade deals, you've got to look after today, and you've got to look after at home. You've got to be competitive, and that's why I think robotics is going to be key, because it's another edge.
Yeah, I agree. And I think the food industry is one of those industries that is incredibly agile all the time. So I can't see any good reason why they couldn't adapt and adopt robotics as part of their normal systems. So I've got a couple of questions to do kind of both ends of the scale, really. So the first one is about how could we support SMEs with these advances, both financially and with training?
Well, I guess the positive answer is that there are a range of mechanisms that government, in the broadest sense, it makes available. There are local initiatives that actually enable universities to actually interact with SMEs in particular, and I just encourage people to actually look fully for opportunities that provide resources to actually give them an edge on those investigations. Is that enough? I don't think it is, but there is a support available.
Yeah, and I think the other, I see two series of SMEs. I see the food manufacturing SMEs who've got the challenge of adoption and capital and confidence and ROIs, and then the other SMEs are the robotics SMEs, I see a great, really it's the robotics SMEs, it's the sort of world that we're operating in at the moment. It's a great space, and you've got to bear in mind a lot of big co's now. So the big robotic companies, the big food processing equipment, they're doing less in-house innovation. They are doing that innovation, but those companies are relying on this pipeline of SMEs to bring in new ideas. And particularly around AI, robotics, machine learning, which Martin mentioned, there's lots of really great people coming out of universities who, quite frankly, they've got amazing futures. I wish I was 20 years younger, but they've got great futures. And if they can build scale, they can be acquired, or they can create scale quite quickly. Challenging, but there's a lovely space, a gap for those businesses to grow in.
Yeah, no, absolutely. And you're quite right. Is the support is available from both ends, both within the food manufacturing and at the robotics level. I'm sure people like the Knowledge Transfer Network have got plenty of support coming there through them that can be used. If you heard that alarm, which you probably did because it made me jump out of my skin, that was us saying that we've come to the end of our question and answer session, I'm afraid. We had many more questions, but what we'll do is basically I'd like to just say thank you to Simon and Martin again for their presentations and their time today. I think we've really enjoyed it. And thank you to everybody from across the globe for attending the webinar today. If we didn't manage to answer your questions, please contact the speakers directly. We've just popped their details on the screen now, so take a note of that and feel free to drop them a line. And finally, we would like to remind you that those of you that are not familiar with IFST, you can find some useful resources on our website, including our COVID-19 Knowledge Hub and online Food Science and Technology magazine. We always welcome new members, so please check out our membership benefits page on the website too. And thank you so much again, Simon and Martin, for your time and for everybody attending today. Thank you very much and goodbye.
Thank you.
Bye. Thank you very much.